Hello everyone, my name is Homero and I'm gonna solve this question for the discrete time signals and system class. I have a discrete time signal x of n plotted below, and it's known that if x of n it's equals 0 for n less than minus 4 and n greater than 1. Give an expression for x of n is a sum of scale and delayed delta function. So I can write any discrete signal as a sum of shifted and scaled delta functions. So I have written these delta functions here, and all I need to do is scale and shift them. So I will see on my plot that for Tn equals minus 4, I have a delta function with amplitude of -1. So based on my amplitude, I can write -1 here and scale my delta function. And to shift my delta function, I need to write my delay of time right here. So I have n equals -4. So my n needs to be -4 and my argument needs to be 0. So I have to write here +4. And when n equals -4, I have my argument as 0 and my delta function won't be 0 at this point. So if I see my next point on the plot, I have x of n equals 1 for n minus 3, so I can write here +1 and scale my function, and then I can write +3 to shift my delta function to this point, and when my n equals -3, I have my delta function equals 1 at this point. My next point on the plot, my x of n equals 2 when n equals -2. So first I scale my delta function multiplying by 2, and then I just need to shift summing 2 to my argument, and then I have my delta function scaled by 2 at n equals -2. Here when n equals -1, I have x of n equals -1, so I just need to multiply my delta function by -1, -1, and then I have already scaled. And to shift my delta function, I just need to sum 1 in my argument. When n equals 0, I have x of n equals 0, so I don't need to write a delta function for this point, and I can jump to the next point when n equals 1. So when n equals 1, I have my x of n equals -2, so I can scale by -2 my delta function, and my delta function is shift to the right for 1, so I can write my argument of delta function equals n minus 1, and when n equals 1, I have my argument as 0, and my delta function won't be 0 at this point. So this is all we need to do to write any discrete time signal as a sum of scaled and delayed delta function.